Okay, so if we are going step by step with the 5 steps from above on this one, the first step says rewrite it in terms of sine, cosine, or tangent. And this one you don't have to, because it's already in terms of sine. It doesn't say anything about the interval, so we're going to use the same interval from the top between 0 and 360. And we're also going to do it in degrees. And probably, you guys are probably better with degrees than you are with radians, because radians are new to you. I'm better with radians. I probably should not have done the problem before it in radians. I probably should have just stayed in degrees. So this time I'm going to try and stay in degrees. Okay, so step number 2 says, make a note of the 2 possible quadrants of termination for theta based on the sine of theta. So on this one, it's got sine of theta is negative. So sine of theta is less than 0. So in this case, I should be in 3 or 4. Because that's where sine is negative. Then it says take the inverse trig ratio. So what I have on the page is sine of theta equals negative square root of 3 over 2. So technically what you're doing is arc sine or inverse sine. So I'm taking the inverse sine of one side, which means you have to take the inverse sine of the other. If this were a calculator problem, you would just punch that right in your calculator, but it's not. So I am now looking for the place where sine is square root of 3 over 2, which is my y value, which means I need 3 fingers on bottom. So I need to fold in this finger. So what's the denominator for this finger? Which one is this? 3. This is pi over 3. So now I'm going to write down pi over 3, but the problem is it's not pi over 3 because the next step says it should terminate one of the 2 quadrants mentioned above, or in step 2, and pi over 3 is not in 3 or 4. So I need the angles in 3 and 4 that end with a 3 on bottom. Good. So I know one of them is going to be here. And that one has to be 4 pi over 3 because what right here, remember, is pi or 3 pi over 3. So this one has to be 4 pi over 3. Or, I'm sorry, I said I was going to do this in degrees. I'm going to do it in degrees. Sorry, this finger up here is 60. So I need the one that goes with it that's over here. So that means that it's 4 pi over 3 would be past 180. So what is that in degrees? 240. Okay, thank you. Sorry, I just think in radians. I try not to. Okay, so this one's 240. And then I also need another one that's in quadrant 4. This one over here. That goes all the way around and back to here. So it's pi over 3, but it's in quadrant 4. Which one is this? 300. Good. Yes? How did I know which part? Okay, because this is sine, and sine is the y value. So I need a 3 because the top number is what your fingers are going to tell you. I need a 3 on bottom because whenever you're looking for your y value, it's your bottom fingers. So 1, 2, 3, which means I fold this finger in. That leaves me 3 on bottom and 1 on top. And then that's the angle. Whatever finger you folded in is the angle. Does that make sense? Okay, so I drew my 240 and my 300. I think that was it. So theta equals 240 degrees and 300 degrees. Everybody okay?
It doesn't mean anything if it's like negative square root of 2.
That just, I'm glad you asked that because this part is what gets kind of confusing. That is what tells you what quadrant you're in. So it's not telling you that it's a negative angle. Now, if they wanted the negative angle, this would have changed. They would have said between 0 and negative 360. And then you would know you're going backwards and you had to get the negative angle. And that is, it can get a little confusing to know whether you're looking for a negative angle or not. Okay, now, look at what they've given us. Decimals. What does that probably mean?
Headaches.
Calculator. our answers to the nearest thousandth of a degree. When they say thousandth of a degree, how many decimal places are you going to have?
3.
3. Okay, so the process is pretty much the same. Sine is positive, so I need to find sine of theta is greater than 0 in quadrant 1 and 2. So they gave me sine theta equals 0.735. I need to isolate theta, get theta by itself. So in order to do that, I arc sine the left, because that'll cancel out sine, which means you have to arc sine the right. Alright, so we're going to plug it into our calculator. I'm going to make sure I'm in degrees here. So I'm plugging in arc sine 0.735. And I got 47.307. Alright, now, I'm not finished though, because my instructions said, give your answer to the near, actually it said, finding 2 values, and I have just found 1. Now, if you remember, I gave you pages, and I told you you needed to keep them. One was called, this is the one in radians, Solving with Radians, and it had this little box that told me how to find the others. The one that's in degrees is called same sign, but different signs. You might need that for a little while, so you get used to this, because we need to find the other one. So it's not quite as straightforward as radians, because when it's in radians, you can just figure out what has the same denominator. But when you're in degrees, you can't really do that, and when you have non-exact answers, you can't do that. So I need to know when it's sine, how I find the other one. Anybody remember or have it there and can tell me how to find it? Do what? Close.
Subtract.
I minus.
Y'all given all the rules, just not the one you signed.
Add the same one.
Nope.
Is it not pi minus the inverse of sine?
It is pi minus that, or 180 minus what you were given. So, which does make a difference. So I have to plug in my calculator 180 minus the angle that my calculator gave me. So I usually just arrow up to it, grab it, and hit enter. So my other angle is going to be theta equals 32.693 degrees. Now, after you've done that, remember, there's also, at that point, you could add 360. You could add 360 again. So you have to check and make sure you're still inside the interval that they gave you, which the interval that they gave me was between 0 and 360, and both of these are. You also probably want to check and make sure you're in quadrants 1 and 2, which you are. Yes, ma'am. Remember, quadrant 1 is between 0 and 90, and quadrant 2 is between 90 and 180. And then quadrant 3 is you add 90 more, and then quadrant 4 you add 90 more of that. So you just kind of have to keep track. That's a good question. All right, so let's try cosine. First thing we want to do is recognize that cosine is negative. Cosine of theta is negative in 2 and 3. So when I get done with this, my angles should be in quadrant 2 and 3. Alright, I'm trying to isolate cosine, which means I have to arc cosine or inverse cosine. I'll plug it into my calculator.
You plug it in with the negative?
Yes, that's a good question. Go ahead and plug in the negative. And that gives me theta equals 118.816. Now, that's my first answer. So then I have to think cosine, what can I do to get my, oh, and my first answer happens to be in what quadrant? Quadrant 2. So that's good. I have the one that's in quadrant 2. Now I need the one that's in quadrant 3. So what can I do with cosine?
Make it negative.
You can make it negative. Now, does making it negative put it in quadrant 3?
No.
So, well it does, but that's not what we want, because we want a positive angle, between 0 and 360. So that doesn't exactly help me? Not exactly. What's my next option? Add 360.
It's this paper, right? The same
Wait,
size?
make it
Yes.
Okay.
Make it negative and then that.
Yes, so we want to make it negative and then add 360. Because if you add 360 to 118, you're above your interval. But if you make this negative and then add 360, I get theta equals 241.184.
Yeah, so you have quadrant 1 also.
And that is in quadrant 3. Yes. Everybody kind of okay? All right, so you try the next one, which is cosecant.
The original thing is this.
As soon as Dylan gets back.